Let's find what the graph of a logarithm is going to look like. Well, in order to graph a logarithm, I need to know or remember my exponential curve. And if you remember, it passes through this point. The exponential curve, y equals a to the x. If I put 0 into that position, y is equal to 1. So when I find the inverse, if you recall, it's switching the x's and y's, or folding about the line, the identity line, y equals x. So what's going to happen then is this ordered pair over here, which was plug in 0, input, output, that's going to switch when I want to graph the logarithm. That's going to switch and become 1, 0. And so it switches axes. Notice in the exponential, I had this horizontal asymptote at y equals 0. So when I'm looking at the inverse, horizontal inverse is vertical at x equals 0. And so what happens then is my graph looks like that. Let's go ahead and check this point right here that we just switched, which was 1, 0. Recall a log is the log of x base a is equal to y. That was the inverse. And in other words, a to the y equals x if I'm taking it out of log form. And if I try that point, let's see, here's my y coordinate. A to the 0, is that equal to 1? Yes, it is. And notice they just switched the axes. So what we're going to do then is we're going to transform these things just as you've done the rest. I want to take my logarithmic curve, and I want to reflect it up and down. I want to take this and I want to flip it. So this piece is still going to hit here, and then it's going to level out. So remember, I just reflected it up and down. So what's it going to look like? Well, y equals the log of x. I'm just going to leave the base off for just a minute. It could be anything. In fact, we could put an a if there I wanted. And let's see if I'm going up and down. That's a y flip. So it must be with the y, so it's got to be on the outside. If I reflect left and right, so again, I'm going to take this regular logarithmic graph, and I'm now going to reflect it left and right. So left and right is an x flip because x-axis goes left and right. So the negative then must be on the x inside. If I'm shifting the graph up and down, in other words, I want to take my original logarithmic graph and I just want to take this thing and move it up or down. Let's see, up and down again is a y shift. So if I go log of x base a, and sometimes we don't like to add 1 on the end because it looks like it's x plus 1. So what we like to do is go 1 plus the log of x base a, and that's equal to y. So that would take this graph. Now we start with this point. I move it up 1. Everything shifts up 1. Shift left to right. That's an x shift. So we have log base a, and so that must be with the x coordinate. And so what again I'm going to do is I'm going to take this red graph, and let's see if it's plus 1, it must shift it back 1. Okay, it works the same way. So this graph then would be shifted back 1 and would come from there. So it actually passed through the origin. So that's how you translate graphs. It's the same way you've done exponents, quadratics, cubics, and so forth.